Tonight's lesson is on 3-3 proving lines parallel. In the past, on 3-2, we learned that if we had two lines that were parallel cut by a transversal, that certain relationships exist between the alternate interior, alternate exterior, corresponding in the same side interior angles. Alternate exterior, alternate interior, and corresponding angles were congruent, and the same side interior angles were supplementary. We can use that information to prove that lines are parallel. So we're going to have a couple theorems and postulates to learn in lesson 3-3. Starting off, there's postulate 3-1, which states, if a transversal intersects two parallel lines, then corresponding angles are congruent. So we're going to do the converse of that postulate now. When we look at postulate 3-2. The converse of the corresponding angle postulate says, if two lines on a transversal form corresponding angles that are congruent, then the lines are parallel. So we can use the information that we learned previously about parallel lines creating corresponding angles that are congruent, and the converse of this is true. So we could say transversals intersect two parallel lines if and only if their corresponding angles are congruent. So we're going to use the diagram below, place appropriate markings to show that angle 1 and angle 2 are congruent. So I need me a pen here. I'm going to show that angle 1, and it's not showing up because it's in white, angle 1 and angle 2 are congruent. Hopefully you can see that. Maybe if I white out the numbers. All right, so those angles should be marked appropriately. There we go. Go to pointer options, pen color. Let's make it green. Angle 1 and angle 2 should be marked appropriately. Very good. That took a little bit of time. Let's continue on. Now we want to circle the diagram that models postulate 3-2. So that diagram was 1 and 2 in the first diagram are alternate exterior angles. So the diagram we want to circle is the second diagram. Let's continue on. Just like we had converse of postulate 3-1, we have converse of the other theorems that we learned also. So theorems 3-4, 3-5, and 3-6 are converse of the alternate interior angle theorem, the converse of the same side interior angles theorem, and the converse of the alternate exterior angles theorem. Theorem 3-4, if two lines and a transversal form alternate interior angles that are congruent, then the two lines are parallel. Theorem 3-5, if two lines and a transversal form same side interior angles that are supplementary, then the two lines are parallel. And finally, if two lines and a transversal form alternate exterior angles that are congruent, then the two lines are parallel. So we now have ways to prove that lines are parallel. So theorem 3-4, if angle 4 is congruent, that's alternate interior, so that will be if angle 4 is congruent to angle 8, then B is parallel to C. Theorem 5, if angle 3 and angle 8, which is the same side interior angle, are supplementary, then B is parallel to C. And finally, if angle 1 and alternate exterior angle with angle 7 are congruent, then B is parallel to C. So we can identify parallel lines based off of these different angles that we have. So how do we identify parallel lines? Which lines are parallel if angle 6 is congruent to angle 7? So underline the correct words, complete each sentence. Angle 6 is congruent to angle 7 is given, because it says if angle 6 is congruent to angle 7. Angle 6 and angle 7 are same side angles. Angle 6 and angle 7 are corresponding angles. Angle 6 is an interior angle, angle 7 is an exterior angle. So I can use postulate 3-2 to prove the lines parallel. Using angle 6 and angle 7, angle 6 and angle 7 can be incongruent, lines L and M are parallel and the transversal is B. So I can prove that lines L and M are parallel using the corresponding converse of the corresponding angle theorem. We've learned about paragraph proofs and two columns proofs. Another type of proof is known as a flow proof. A flow proof is kind of what you think it is. It's a flow chart, flow diagram that is used to show the flow of a problem from either down to bottom, left to right in this case. So we're given that angle 1 is congruent to angle 7, and we want to prove that angle 3 is congruent to angle 5. So we first start off what was given, and that's angle 1 is congruent to angle 7. We look at our drawing, and we can see that angle 1 is congruent to angle 3 by the fact that vertical angles are congruent. Using the transitive property, if 1 is congruent to 7 and 1 is congruent to 3, then 3 is congruent to 7. So that's the transitive property of congruence. I can say that 7 is congruent to 5 because they are vertical angles, and therefore 3 is congruent to 7, 7 is congruent to 5, 3 is congruent to 5 by the transitive property of congruence. Just a different way of doing a proof, but still the same thing. You're given a reason, and you have to you're given a statement, and you have to give a reason to why that statement is true. All right. Another thing we can do is determine whether lines are parallel. Given that angle 1 and angle 2 is congruent to angle 2, you can use the converse of the alternate exterior angles theorem to prove that lines R and S are parallel. What is another way to explain why R and S are parallel? Justify your answer. So first, angle 1 is congruent to angle 2. That was given. Angle 2 is congruent to angle 3. Vertical angles are congruent. And we say angle 1 is congruent to angle 3 by the transitive property of congruence. Angle 1 and angle 3 are corresponding angles. So what postulate and theorem can you now use to explain why R is parallel to S? And obviously the answer would be the converse of the corresponding angles postulate. Finally, the last thing we're going to do when we have parallel lines, again, it's a little bit of algebra, which some of you like. What is the value of W for which C is parallel to D? So we're going to underline the correct word to complete each sentence. The marked angles are on the same side of the transversal, and by the corresponding angle postulate, if C is parallel to D, then corresponding angles are congruent. So we set up our problem, 55, or 3W minus 2 equals 55. We add 2 to both sides, 3W equals 57, and the value for W is 19. All right, so the next slide is going to have your answers to your review. So you should have done that at the beginning. Again, it's going to be a normal routine now. At the beginning, do your review. Go through your vocabulary review, and then your vocabulary builder. Our word for today is exterior. I believe interior was the last word. So once you have completed the vocabulary part, the review section, you can check your answers on the next slide. So if you want to pause now in case you didn't finish the review part. And then finally, the lesson check part. Please check your lessons. Make sure you understood the lesson. If you have any questions, ask. Our problem for the lesson check is a classmate says that line AB is parallel to line DC. Based on the diagram at right, explain your classmate's error. So here are the answers to the review. You're probably going to have to hit the pause button because I'm going to go pretty fast. I want to be under 10 minutes. There's the answer to the vocabulary builder. Darn, I'm not going to make 10 minutes. Here's your lesson check answers. And so tomorrow when you come into class, we'll get started on the 3-3 reteaching sheet real quick, knock that out. We'll do 3-3 and probably we'll get over 3-4 tomorrow when we're doing with parallel and perpendicular lines. So please watch the video and I'll see you in class tomorrow. Hope you have a good evening.